so everyone should have all their supplies. The first thing we're going to do is open up our science notebooks. So let's do that. Let's open up our science notebooks, please. Head to your table of contents. Now that should be in the very back of your composition notebook, right? All right, so go ahead and head there. It should look something like this. On the very back, you have your table of contents in the center. You have your date. So let's fill that out. Since this is our first notebook entry, let's fill that out together. Let's pretend this is your piece of paper. You have date, title, and page number, don't you? So let's fill those in. First of all, what is today's date?
25th.
8/27.
Really?
Yes, that is today.
25th was Tuesday.
Now then, our title, we're going to make it really simple. Let's just make our title Science. Ooh, not too hard, right? And if you're unsure of how to spell it, it's right here on the board. Sometimes it's made. Science is misspelled from time to time. All right. And then, of course, let's add our page number. For today, we're all going to start on the same page because it's our very first entry. So we're all on page number 1.
Wait, what was the date? I don't have my glasses.
August 27th. And you're welcome to move, if you want to move up here, you can see better. All right, so I'll give you a moment to fill in your table of contents. And then we're going to move to the first page of our notebook. All right, so everyone travel to page number 1. All right, show me a thumbs up if your table of contents is rip-roared and ready to roll.
Go to our
All
lectures.
right.
In the photos.
There you go. See better. All right, I'm going to erase this because we all have our table of contents ready. So now then, let's move to the first page, page number 1. At the tip top of our page, let's write today's title. And what was today's title?
Science.
Science, yes. So go ahead and write science, nice and large, at the top of the page. I have a quiz printed off. And that quiz covers section 1A, which was your homework, wasn't it? Remember, you were supposed to read section 1A yesterday and answer your 7 questions on it. What we're going to do in today's class is review that. Make sure you know all those answers. And then Monday, we will take a quiz. Your first quiz in science. All right. So let's get things rolling here. The first thing we're going to do is write in a definition for science. Now, I believe that was the first question in your homework, wasn't it? So we're going to make sure this is in our notes because, I mean, this is important. Science is what we're learning all year. Science is this. Science is knowledge. It's knowledge that we gain through careful, systematic investigation. So in your notebook, let's define science. You can see this is my pretend notebook page of science, right? The first line, let's write the word science, underline it because it's a key term, and then we're going to define it. So you ready for your definition? All right, here is the definition of science. Science is the knowledge gained from careful, systematic investigation of the natural world. Say what, I'll pull the screen back down. Now there's no line still, you can see it all.
Oh, there it is.
All right, so in science, in this class, we're going to be gaining knowledge, of course. We're going to be doing investigations, of course. But notice how we gather that information. How do we get that knowledge? Through careful, systematic investigation. You guys do careful, systematic investigations all the time. If something's systematic, it's procedural. In fact, I think that was your second question in your homework, wasn't it? What does it mean to be systematic? You were systematic this morning. You have a system. Probably first thing this morning, your alarm clock went off.
I didn't.
annoying sound, right?
That was the
You
worst.
rolled out of bed, you probably changed your clothes, maybe took a shower, you probably ate a little breakfast, brushed your teeth, hopefully, right? Then you got in the car and you came to school. Did anyone ride the bus?
No.
There's a
Oh,
bus.
good, good thing, because if you rode the bus, you'd be at the wrong school.
Okay.
All right, so you went through systematic steps to get here, right? In science class, in this class, we're going to use systematic steps to learn about the subject of science. Now, in this class, we're specifically learning about life science. So, life science, you think we're going to learn knowledge in life science?
Possibly.
Yeah. Do you think we're going to use systematic procedures to do it?
Yeah.
Absolutely. Do you think we're going to do any investigations? Absolutely. So life science is this. Life science is knowledge gained through scientific investigations, but we apply it all to living things. So basically it's science about life, isn't it? So we're going to get to study living things, we're going to get to study once living things. Now we have some upper level classes here at Providence that study the same topic, but they give it a bigger, fancier name. Does anyone know the upper level class, what we call it?
Biology.
Biology, yes. Biology means life science. It's the exact same thing. So we can call life science biology. So let's make sure we get a definition for life science and biology in our notes. Now, if you look at the word biology, it tells you exactly what it means. Ology means the study of, right? Bio. Can you say bio?
Bio.
Bio means, does anybody know?
Life.
Life, exactly. So biology is the study of life.
That's
Biology.
Latin.
That is language and science. All right, so already we have covered and we've reviewed some of your homework from yesterday. Now, another piece of homework that you had was to read over 12 safety rules. How many of you guys read over those? Awesome. You should have read through them and signed the paper and had a parent sign the paper as well, right? Now, here are those 12 science safety rules. Is everyone finished with this?
Oh, no, hold on.
Wait, we have to write it down.
All right, I'll leave it here. Yes, you need a definition for life science, and make sure you include biology in there as well.
Oh, I just wrote biology instead of life science.
That's fine.
And then I put study life.
As long as you know those terms are interchangeable, okay? All right, so our science safety rules, there were 12 of them. You should have looked over them very carefully. And it's very, very vital that you follow those safety rules. Yeah, you guys have been stellar just the last few days. So I'm confident you'll do awesome. Now, if we don't follow those safety rules, is there any risk?
Yes.
Absolutely. Now, the next thing we're going to do is look at 3 ways to think scientifically. Now, go ahead and put these in your notes, please. But I'll go through them and tell you some more. So, the first thing, we need to be curious. Curious about science. Curious about the subject. Curious about life. Curious about God's creation. All right, the second C word is we want to make sure we're cautious. Cautious in our investigations, make sure we're safe in our investigations, and cautious to make sure we're considering the proper worldview. And then finally, the third C word is commitment. We want to ensure that we're committed to being safe, committed to being curious, committed to finding the answers to some really cool questions in this class. So basically, these 3 C's will help us be really good 7th grade scientists. Now, what we're going to do next is consider observation. Observation is so important in science class. I can put any item on your desk and ask you to observe it, right? That's using your 5 senses. You can see that item, you can feel that item, you can touch it, you can smell it. Ugh, you can taste it. No, I'm not gonna taste that, it'd be nasty. So you use your five senses to gather information, don't you? We call that observation. And I know this is probably a basic word, you're probably like, yeah, I know this. But let's go ahead and define it, because we use observations to also build inferences, and we're going to discuss inference as well. And I think you covered that in English class.
Yeah.
So you get it a second time, another dose of it here in science. So here's observation. It's basically when you gather information by using those five senses. You can observe anything, can't you? Other than ideas. Anything that's a physical item, you can observe it to gather information about it. So I'll give you a moment to make sure you have this definition in your notes. I believe this was one of the answers to one of your homework questions as well. Now the cool thing is we can make observations to learn about the designer and creator. For example, this Dell computer. I can examine this Dell computer, I can look at it, I can examine it, and through examining it, I can kind of look into the mind of the engineer, the one who created this Dell computer, right? Whoever engineered it and designed it, I can kind of learn about them by observing this computer. The same is true of God. We can look at the natural world around us. Anything and everything He's created. We can look at it, we can observe it, we can learn about it, we can learn all the awesome details about it. And you know what? We can learn about God through that, can't we? So observation is incredible. We can use it to learn about our natural world, and we can use it to really indirectly learn about God Himself. Isn't that kind of cool? All right, so curiosity. In this class right here, I want you to ask deep questions. Ask the why questions. Ask how things work. Why does it work this way? Be curious, okay? And like I said, you don't have to write this one down. You already have curious in your notes, or curiosity. But I want you to be curious in this science class. I want you to be cautious in the science class. Make sure you're following those safety rules, right? Now, as we're cautious, we need to be careful. We need to be careful to know the difference between an observation and an inference. There's a big difference between the two. An observation is something you see directly. You see it, touch it, smell it, taste it, all that fun stuff. An inference is deeper. You have to use your brain power to make an inference, don't you? Now you use observations to bring you to an inference. So what is an inference? A logical conclusion based on evidence. Let's add that to our notes. This might not be exactly word for word how your English teacher defined it, but I can promise you it's the same concept and the same idea.
It's very similar.
So inference, a logical conclusion based on gathered evidence. So the cool thing is we can make an inference using observations. But there's definitely a difference between an observation and an inference. For example, let's pretend for just a moment. Let's pretend that we are, I don't know, maybe at a park, and you see an individual who's wearing dark glasses, okay? Dark glasses, and they have a white rod in their hand. Okay? And that individual's seated on a park bench. Now, you're sitting there, you're observing, right? You're using your observation skills. And you can put all the puzzle pieces together, and you can figure out what's going on. So I want you to do that. I'll act it out, and you see if you can infer what's going on here, okay? If you think you know the answer, don't shout it out, but just, store it away in your head. All right, so let's say this person gets up from the park bench, begins doing this.
Did it just hit you?
Alright, up.
Every hand's in the air. You guys know exactly what's going on, don't you?
Mm-hmm.
So what is it?
They're
What do you
blind.
infer is going on? Right back there in the back.
He's blind.
He's blind. Wearing the dark glasses. And someone this morning said, why do blind people often wear, dark glasses? Maybe to hide that their eyes look a little different, maybe than our eyes. But obviously the white stick gave it away, right? And you guys know that if someone has a white cane, that usually means
They're
they're blind.
Why does that have to be
Or they're a
blind?
shepherd.
So, you use the power of observation to infer about that situation. You do that all the time in your life, don't you? You use observation to build inferences. But do you see the difference between an observation versus an inference? They are different, aren't they? They both work together, but they are different. All right. Has everyone defined inference?
Yep.
Nice.
Inference.
You're getting a double dose of that word, aren't you? You're getting in English class and in science class. Wonderful. It's almost like your teachers planned that. No, we didn't really. All right, now the next thing, and you don't need to write this down, but our commitment in this classroom is I'm going to be very careful. Careful that you guys are safe. Also careful to evaluate our observations and our inferences, and we're going to consider everything in light of God's Word, okay? So we'll get into that a little bit more. Yes?
Is it okay if we go to the next page in our notes?
Absolutely. Absolutely. If you're finished with page 1, then you can just flip it and then cover, fill in the back side. And use page 2. That's totally up to you.
Okay.
I know some people write really big and some people write really small. So,
I just have a lot of information here.
yeah. All right. Now then, we're going to cover 4 limits of science. How many?
4.
But your book tells you 6. In fact, that was one of your homework questions. All right, so make sure, double check your homework. It should be in front of you. Make sure your answers are there. 4 of them that I want to specifically look at in this class. Here's the first one. All right, guys, we're continuing that lesson just in another setting now. So continuing on with our 4 limits of science. In our classroom here, we're going to see how science deals with the observable. Science can't deal with the unobservable, but rather is limited to what we can see, taste, touch, smell, and use our 5 senses with. So that's one limitation of science. Now then, what I'd like to do, and I did this with the students, is I led them through an activity basically seeing the difference between an observation versus an inference. So as you can see on the screen here, what we did is we pretended we were a paleontologist, and we had basically found all these fossils in different rock strata, and then we went through each one of these statements to see, is this statement an observation of this fossil site, or is this an inference of this fossil site? We did this to demonstrate the difference between an observation versus an inference. So the first one, for example, it says there are tracks from 3 different animals in the rock. That's something we can infer based on information. We can see that there are 3 different sets of tracks. They don't look identical, so we can infer then there must have been 3 different animals or species within the tracks that we see total. And the second one, it says here one animal was chasing another animal. Can we make that direct observation about this fossil dig? Absolutely not. There's no way we can see that one animal was chasing another. Now, on the other hand, we can infer that based upon maybe the depth of the tread of the tracks, maybe it gave the appearance of running. So basically that's an inference. That would in no way be an observation. Also, the third one here, 2 different animals died in this location. Well, if all those bones of that one living organism were there together, then we can say that, yes, I observe that there are 2 animals here that have deceased and died in this one spot. On the other hand, if the bones are scattered here, there, and everywhere, if something's picked through the bones after the animal died, then that would be an inference. So you can see how observation inference does tend to be fuzzy at times, but there is certainly a difference as well. Now, it says here, when the animals walked here, the ground was wet. Well, in order for the impression to be made, then the ground, yes, had to be wet. So you can see here through each statement, we can say definitively if it's an observation or if it is an inference. And inferences are built and created by our observations, but inferences are not direct observations. So we learned the difference between the two in our classroom setting. Now the second limit of science that we discussed was that scientists are often influenced by their biases. And we defined that. A bias is simply something that someone wants to believe. So, for example, I am influenced by the bias that I hold that God's word is true. That is my bias. That's a great bias because we depend upon a faithful and true God. Now, we also have the example of Bill Nye. Bill Nye has a bias that there is no God. So that bias influences how he sees and views science. You can see that in his video productions and his materials. In this class, we're going to always approach things from a biblical point of view. Now, a third limit of science. Science cannot make value judgments. In other words, we don't make judgments on opinions in science. We don't test opinions. I could say, for example, if I had a cup of coffee, this is the best cup of coffee I've ever had. Well, that's an opinion. There's no way to test it. One person's opinion may be different from another person's opinion. So in science, we stick to measuring facts alone. So I could take that same cup of coffee and I could measure its temperature. I could measure other attributes about it and its chemical composition. But that would be scientific versus opinion-based. So science does not make value judgments. Now, the fourth and the final limitation of science that we discussed in class. Science cannot prove universal statements. And we defined that. In fact, that was on the homework. The students had to write a universal statement. So a universal statement is this. It's a statement that excludes every other possibility. So for example, let's say I said there are no Canadian night crawlers in the state of Arkansas. Okay, that's a universal statement. Now, can I test that statement? I could, but that's going to be an incredibly hard and long job to dig up every square inch of Arkansas to see if there are any Canadian night crawlers. So you can see universal statements are ones that we cannot test, we cannot validate. An example given in the book was, life does not exist on Mars. Well, we can't definitively as scientists back that up because we haven't researched every square inch of Mars. So you can see that's a universal statement. Science cannot prove those or disprove those. So that's our fourth and final limitation of science. Then we went on to define presupposition. And presupposition is often like a bias. It's basically an idea that you assume to be true. And I used Bill Nye as an example in our science class. He has the assumption that there is no God. Therefore, that influences his science. I, on the other hand, have the assumption that yes, there is definitely a God. And boy, that influences the way I view evidence. That influences the way I view fossils in the fossil record. So you can see our presuppositions definitely influence our interpretations of the world around us. In this specific class, my commitment to the students and to the parents is that we're going to approach science from a God-centered point of view. We're going to do that by being curious about God's creative world. We're going to do that by exercising caution and being safe in our lab experiments. We're also going to be safe in that we're going to approach things from the correct biblical worldview. We're going to approach things from God's perspective, not the theories and ideas of man. And then finally, my commitment is to always use biblical presuppositions. And I have confidence that I can do that because my confidence is in the one who gave us his word, in God. And we know that God, he is truth, and he's given us his truth through his word. So that's my commitment to the students. My apologies that I had to do this video in 2 parts. The class I chose to do the video in was cut extra short. We had a wonderful chapel, it went a little bit long, so I didn't have enough time to get in this last little tidbit. So that's, I told the kids, I'll post this on our Google Classroom. They can get the rest of the lesson this way. And also remember, Friday's work, there are 2 assignments. There's one called Laboratory Safety. It is also included on the Google Classroom account as well. Basically, it is following classroom safety rules. There are some questions regarding that. And then the students get to start exploring a simple experiment. It's very simple. In fact, I know some of the students have done this experiment before, but they're taking a penny or another coin. If they want to use a different coin, they may. But they're going to drop droplets of water on that penny or coin. They're going to do that until it bubbles over and then falls off. Now, they're going to count the number of total drops they get and collect on their coin. They'll do that a total of 5 times and record their data on the data sheet that I provided in class. If you don't have that, if your student doesn't have that, then that can also be found on the Google Classroom site as well. Now, they record that data and then they get to do the whole experiment again a second time. But the second time they're going to put 1 drop of water, 1 drop of soap into their water to see if that influences the number of water droplets on that penny or that coin. So I hope the students have fun with that. Feel free to help them out with it as well. We're going to bring the data back on Monday. We'll also have a quiz on Monday as well. So I hope you guys have a blessed weekend, and thank you for your patience as I had to do 2 video segments for this particular lesson. Have a blessed weekend, guys.